Welcome to another video. So in this video, I'm going to show you how to use this thing, which is called a unit circle. We're going to discuss many examples, some that have a little bit of math in them, where we add and subtract some different things using the unit circle. I'll show you how to deal with coterminal angles. So what happens when you do more than one revolution or some negative measurements? So it'll be clockwise angular movement. We'll talk about what that means. We'll talk about how sine is really just the y-coordinate of a point on the unit circle, and cosine of whatever angle we have is just the x. So we'll deal with that. And the whole idea is, can you find the angle, identify your y for sine, x for cosine, and divide them for tangent. And then we'll find the reciprocals for our other trig functions. So we're going to deal with that. I'll show you exactly how to do it. So this is what is called a unit circle. And even though it doesn't look like it, this radius is one unit of measurement. So what I've done here for you is created, I think, the best unit circle like ever. That's why I use it all the time. And there's a whole lot to it. So I'm going to spend the first about 5 minutes explaining how this works and what all is going on. There's one that you can find on the internet pretty much anywhere, any of them will work. But one that looks very similar to this. I didn't make it up, but it's very valuable. So here's what happens. I'm going to start by telling you that because this radius is 1, we can relate arc length and radian degree measurement of angles to sine and cosine very, very easily as it relates to the y and the x coordinates of points on the unit circle respectively. Now, that's a lot of words, but here's what it means in practicality. If you look at any one of these points, cosine of whatever this angle and sine of whatever this angle is given by your x and your y coordinate. I've color-coded it. So cosine is red, sine is blue. Even as far as the signs themselves, positive, negative, go in each of the quadrants, 1, 2, 3, and 4. I've also talked about what trig functions are positive for each of those quadrants. All of them. Sine only, cosine, tangent only, and cosine only, and the reciprocals of those. So cosecant, cotangent, and secant. So that's how this works. I've also given degree and radian measurements for all of these angles. These are the most common angles that we really deal with. And if you just follow the color coding behind it, it comes out really nicely. In order to get tangent, I've written this as sine over cosine. That's x over y. For any of these angles as well. I've omitted the angle, so like theta or t, because they're universally used. And we have more of the idea here that sine is the y-coordinate, cosine is the x-coordinate. That's why I did it like that, so that you can really see that. So we're going to get right into it. We'll talk about, firstly, how to find an angle on a unit circle, and then what in the world we do. There's a definite order of thought in how to find all 6 of these standard trigonometric functions. So let's get right into it. Let's look at 2 pi over 3 or 120 degrees. Now, I am going to mostly use radian measurements versus degrees, but they're interchangeable. So whether you have sine of 120 degrees or sine of 2 pi over 3, as far as a unit circle is concerned, they're interchangeable. If you converted them, you could convert between the two very easily. That's what I mean by interchangeable. So here's what we're going to do first. We are going to find sine and cosine first for any of these angles that we're looking at. Then we'll find tangent, and then we'll reciprocate all 3. So let's take a look first at where 2 pi over 3 is. 2 pi over 3 is in quadrant number, let's see, 2. In quadrant 2, so sine should be positive. This says quadrant 2. It says cosine will be negative and sine will be positive. Red remembers cosine, blue is sine. Why? Look at where this point is. At 2 pi over 3, when the angle sweeps that out, the point is right here. Here's the point. X's will be negative, Y's will be positive. That's exactly what it says. Cosine will be negative, that's X. Sine will be positive, that's the Y. And so we're going to write those down. So sine of 2 pi over 3 is exactly what the y-coordinate of that point is for some reasons I explained in the previous video. That's square root of 3 over 2. Cosine of 2 pi over 3 is the x-coordinate of that point, for some reason I explained in the last video. That's negative 1/2. Tangent takes a bit more work. Now, there are other tables that you can just look at, and that's fine, but I really want you to understand where it comes from, not memorize a table. Tangent is taking the y coordinate and dividing by the x coordinate. Remember, this really creates a right triangle right here, where the height of it would be root 3 over 2, that's the y, and the, let's say, length of it, I suppose, would be negative 1/2. We use it with the sine. Dividing y over x would divide opposite over adjacent for a right triangle, or root 3 over 2 divided by negative 1/2, or sine over cosine. Blue over red. However you want to think about that, that's what this does. So at 2 pi over 3, tangent would take y divided by x, or sine divided by cosine. We can do the math really quickly. You can use your calculator if it has the ability to give you back square roots. The ones I recommend always do. You can do it in your head though, kind of nicely with a lot of these common ones. If we divide by negative 1/2, so sine over cosine for 2 pi over 3, then we're going to reciprocate and multiply. Your 2's are going to cancel. You're going to get negative square root of 3. Once we've done that, now it's time to find the reciprocal functions for sine, cosine, and tangent of whatever angle we've just talked about. And it's really easiest to do it after you've done sine and cosine. You just reciprocate them. That, to me, is a lot easier than looking back here and reciprocating and doing a lot of the math in your head. So unless you have to find just one of them, usually if you find all 6, find sine, then cosine, then tangent. Create a pattern for yourself that works every time. So cosecant says, take a look at sine of the angle and reciprocate it. That's 2 over the square root of 3. Normally, we have to rationalize that denominator. So you multiply by the square root of 3 over the square root of 3. So here's 2 over square root of 3. Rationalizing, we get 2 square root of 3 over 3. That's what cosecant of 2 pi over 3 would be. It'd be 2 square root of 3 over 3. How about secant? Well, secant takes a look at cosine and reciprocates it. That's going to be negative 2. That's a kind of easy one. And then cotangent does the same thing. It reciprocates tangent. So negative square root of 3 over 1 becomes negative 1 over square root of 3. By the same exact logic as this, we're going to get negative 1 times square root of 3 over 3. That is how to find your trig functions stemming from the use of these things called the unit circle. Now, obviously, you're probably not going to want to carry one around this big when you're doing like a test or your homework or something, but print one out, have it in front of you. Use it as little as possible. What do you mean? Start trying to memorize these things. Not memorize why they work, that's important to understand that, but it will come to you a little bit better if you're not always looking at your unit circle and like, oh, I don't know what sine of pi over 2 is. Let me look at my unit circle. Sine of pi over 2, we should pretty much identify that as 1 almost all the time. Sine of pi over 2, you go, yep, that is 1. The more that you memorize it, the less likely you are to make some mistakes later on in math, especially if your teacher does not let you have a unit circle on a test or something. So use it until you get used to it. And then try to not have it right next to you all the time. See if you can do it without it. It's valuable. It really is valuable. Make your math much more efficient. That's speed with accuracy. Okay, so we don't really want to be relying on it all the time from here on out. For now, of course, it's brand new, and that's totally okay. I generally let students use it on a test for trigonometry, but as we get closer to like Calc 1, Calc 2, Calc 3, it kind of goes away. And you're just required to know it. And so that's what I want to start training you on. Now we're going to deal with one more, well, actually I don't do much about it, but I want to show you something called a coterminal angle. So let's say that we took a look at 8 pi over 3. Well, 8 pi over 3 is not on my unit circle. That's true. It's actually more than 1 full revolution. 8 divided by 3 is, well, let's see. Think about this for a second. 8 pi divided by 3, 8 over 3 is 2 and 2/3. So 8 pi over 3 says I'm going to go to 2 pi and then 2/3 of a pi. That's what that means. Here's what it would do. 8 pi over 3 says you go all the way around this. That's 2 pi and then 2/3 of a pi. 2/3 of 1 pi. You can count like that. If you wanted to count thirds, you can do it a different way. I want to count 8/3 or 8 1/3 of a pi. Just count the denominator of 3's. So here's 1, 2, 3. Remember, 3 over 3 is 1. 4, 5, 6. 6 over 3 is 2. 7, 8. That's the same thing as 8 pi over 3, or 480 degrees. Take 480, subtract 360. You're going to get 120. The sine, cosine, tangent, cosecant, secant, and cotangent of 8 pi over 3 is going to be identical to the sine, cosine, tangent, and the reciprocal functions of 2 pi over 3. The 480 degrees works out the same exact trig functions as 120 degrees does. So most of the time what we do is we try to figure out what these trig functions are on one rotation. If we get more than that, it's just going to match up to something that we already know in one rotation. And that's something that we can do. So I wanted to point that out to you. I'm not going to redo it because we get the same exact things here. So no matter whether you make one rotation or 50 rotations, where you end up is what matters as far as sine, cosine, and tangent are concerned. Now that is going to be very important when we get to graphing, because when we get to graphing, we're going to notice how it oscillates. It repeats every so often. It's called a period. So every so often you're just going to get a repeating graph and a repeating graph and a repeating graph, and the outputs will repeat themselves time and time and time again. And that's what we're noticing here, going more than one full revolution. Let's get right after it again. We're going to take a look at pi over 4 and find all of our 6 standard trigonometric functions from that pi over 4. Remember, pi over 4 and 45 degrees are exactly the same. So you can see it written both ways. Sine of 45 degrees is going to be exactly the same as sine of pi over 4. I just have that on there so we get used to it. Mostly we're using radians as we continue. So I'm going to use that the most often, but please don't let that sway you. Please understand that either way, you're going to get the same exact relationship amongst the point and the angle. So sine of pi over 4, we got to locate it first. Pi over 4 is in the first quadrant. In the first quadrant, all of your trig functions are positive. Why? Because both x and y are positive, and because the trig functions relate to the points x comma y, they're going to retain those same signs. And so we're going to look at pi over 4, say, hey, that's right here, that's 45 degrees. Sine of pi over 4 or 45 degrees is the blue one, that's y. That's root 2 over 2. That's also true of cosine. You see, cosine is the x-coordinate. That's also root 2 over 2, the red one in this case. And we've seen that right there. Well, what's going to happen with tangent? Well, tangent of pi over 4, it's not shown here. It's shown here. Tangent says you have to take the y and divide by the x. Well, the square root of 2 over 2 divided by the square root of 2 over 2 is 1. So tangent of pi over 4 is 1. Let's move on. Once we've done that, found sine, cosine, and tangent of the appropriately given angle, whether 45 degrees or pi over 4, in this case, quadrant 1, we're going to move on to the reciprocals. But I do want to show you something. Notice how all of them are positive. It says both x and y are positive, sine and cosine are positive, and dividing a positive by a positive will also give you a positive. When we reciprocate that, none of the signs are going to change, although these should also be positive. This will have the same sign as this. This will have the same sign as this for this. For anything that's not a quadrant angle, I can't say that about quadrant angles because some of them become undefined at those values. But for anything inside of in a quadrant, you're going to have the same sign. So let's reciprocate. Cosecant reciprocates sine. Notice how I've matched up for you. I want you to make those connections. Cosecant reciprocates sine. So 2 over the square root of 2. We're going to rationalize very quickly. 2 over square root of 2 gives you 2 square root 2 over 2, or just the square root of 2. For the exact same reason, because these are identical, you're also going to get the square root of 2 for secant. So Secant would say reciprocate cosine of whatever the angle is. So secant of pi over 4 is a reciprocal of cosine of pi over 4. We're going to reciprocate and rationalize. Well, 2 over square root of 2, we'd rationalize and get the square root of 2 again. They are identical for pi over 4, sine and cosine. Cotangent is a reciprocal of tangent for whatever angle you have. 1 over 1 gives you 1 over 1. Notice, this divided by this. Or, well, actually, this divided by this for cotangent. Either way, we'd get 1. I hope you're able to follow me. I hope you're seeing that it's not all that hard, but it's very easy to make mistakes on it. So we need to be very used to our unit circle and starting to really get what's going on here. Let's take a look at 7 pi over 6, or 210 degrees. Let's find it on the unit circle. Let's find sine, cosine, tangent, the reciprocals, and then move on from that one. So 7 pi over 6, let's find it first. 7 pi over 6, you can count them. You should be able to count them. Here's 1 pi over 6, 2 pi over 6, 3 pi over 6. That simplifies to pi over 3 and pi over 2. 4, 5, 6 pi over 6. 6 pi over 6 should give you pi. It simplifies. And 7 pi over 6. And that's where it is. But think about how we're counting. I'm going to start training on how to count the pi over 6 as pi over 3s. So that way when it's not on a unit circle, you don't get stuck. And so 7 pi over 6, yeah, we can find it, but count it. Make sure you know how to do that. If we want to find sine, cosine, tangent, the reciprocals of 7 pi over 6, well, then we're going to start with sine. Sine is the first one we come to right here. That's the blue one. That's the y coordinate. It's negative. Why is it negative? Really think about this. At this particular angle, it creates a point on the unit circle that's in the third quadrant. In the third quadrant, x's are negative. Look at the x-axis. Y's are negative. Look at the y-axis. Both sine and cosine, therefore, because x's and y's are both negative, those should both be negative. But tangent should be positive. Why? Well, a negative divided by a negative, which is what tangent does, takes sine divided by cosine, will become positive. And that's what this says. It says sine's negative, cosine's negative, but tangent here is the only one that's positive, and cotangent will be as well. So let's go ahead and do it. Sine's going to be the y coordinate. So for us, sine's going to be negative 1/2. Cosine's the x, so negative root 3 over 2. Tangent's going to divide them in the particular order. Sine over cosine, y over x, opposite over adjacent. Remember, this would be the opposite is y over the adjacent, which is the x. If we simplify that, remember they're both negative. So negative divided by negative is a positive. If you reciprocate and multiply this, reciprocate and multiply, the 2's will cancel, the negatives will cancel, but you'll get 1 over the square root of 3. We really shouldn't leave it. We're going to rationalize by multiplying the square root of 3 over 3. Square root of 3 over the square root of 3. We're going to end with the square root of 3 over 3. Our reciprocals can be nice for things that don't have square roots in them, but for square roots, we typically have to rationalize. So cosecant, notice I'm not even looking at the unit circle. I already have that down. I have y, I have x, I've got the division of those two things. Reciprocate, don't change the sign. We're going to get negative 2. Reciprocate, don't change the sign. We're going to get 2 over the square root of 3, negative. Can you tell that you're going to get really good at rationalizing denominators? Multiplying by square root of 3 over 3, negative 2 square root 3 over 3. And lastly, cotangent, don't reciprocate this one. Don't do that, because you have to rationalize again. You know what you're going to end up with? Reciprocate that. If I reciprocated that, I get the square root of 3. Which is exactly what you'd get if you took this, reciprocated, and rationalized. You'd end up just getting the square root of 3. I think I actually did that on a previous example so you could follow the steps, but let's be smart about it. If we're just reciprocating, pick one that is 1 over something. That's kind of nice. Hope that makes sense. We're going to come back. We're going to start looking at something in quadrant 4 and then some negative angles, so swept out clockwise. All right, let's take a look at just a couple more before I give you some special cases and how to do some kind of arithmetic with some sine functions and cosine functions. So let's take a look at 5 pi over 3. Let's locate it, identify the quadrant, whether sine and cosine are positive or negative, identify sine and cosine, the tangent, and then the reciprocals. 5 pi over 3, or 300 degrees. Here's 1 pi over 3, 2 pi over 3, 3 pi over 3, 4 pi's over 3, and 5 pi's over 3. So we're counting thirds. That's, of course, in quadrant number 4. 300 degrees is also quadrant number 4. Now, if we identify that, we can easily see sine and cosine. So sine is going to be negative square root of 3 over 2, and cosine is positive 1. Wait, positive? Why positive? Look at quadrant number 4, where this is. In quadrant number 4, our x's should be positive. That means cosine should be positive. Our y's are negative. That means sine should be negative. Associate that, sine with y, cosine with x. Tangent should be negative. Why? Because a negative divided by a positive is a negative. The only one that's positive here is cosine and secant, because that's a reciprocal of cosine. And that's what this says. Cosine's positive in quadrant 4. Cosine's positive, sine's negative, tangent will be negative also. So let's go ahead and find that. Because sine deals with the y coordinate and 5 pi over 3, that's negative square root of 3 over 2. And positive 1/2 for our x, and therefore our cosine for the point that's on the circle at that particular angle. Tangent divides them. In that order, y over x, sine over cosine for that angle. The 2 and the 2 are going to simplify when I multiply and reciprocate. That gives me negative square root of 3. Now the reciprocals of those are going to give us our other functions. So negative 2 over square root of 3, you probably have recognized this is going to be negative 2 root 3 over 3. So don't be afraid to reciprocate quickly in your head. You're going to get very used to these. Secant is going to be positive 2. We already talked about how secant was going to be positive. And cotangent, reciprocate that negative square root of 3. That's negative 1 over the square root of 3, or negative square root of 3 over 3. And those are the 6 common trig functions that we have for that particular angle. All right, I'd be remiss if I didn't put in a negative angle of some type, so I'm going to do that. I even have it on at least the 4th quadrant negatively, just give you kind of a head start on what to do here. So let's take a look at negative 3 pi over 4, or negative 135 degrees. So one way that we can deal with this is to sweep this out by counting like pi over 4s, or counting and taking 360 and subtracting off that 135, and what's going to give us is some sort of an angle positively. So we can do that. I prefer just to count them, just get used to it. So negative 3 pi over 4 is, here's negative 1 pi over 4, 2, and 3. Negative 3 pi over 4 is coterminal with 5 pi over 4. You're going to get the same exact sine, cosine, tangent, all these trig functions as if you had 5 pi over 4, or 225 degrees. So that's what we're going to be looking at. Again, that's 1, 2, 3 swept out clockwise. That's negatively, and it terminates right there. So that's what we're really looking at, that just like 5 pi over 4. It's actually going to lead to some identities later on. We're going to see that, oh, there's certain things we can do with negative conversions to positive types of angles for our trig functions. So let's go ahead, let's do that. If we look at 5 pi over 4, or 225 degrees, notice what I said. 360 subtracting 135 is going to give us that 225 degrees as well. So let's look at that. Sine should be negative root 2 over 2. Cosine is negative root 2 over 2. This is in quadrant 3, not quadrant negative 2 or something. Quadrant 3, it's going to have sine and cosine both negative. Tangent positive. Why? Negative divided by negative is going to be a positive. That's showing that to us. So negative root 2 over 2 for both sine and cosine of that angle. Positive 1 for tangent. Can you see why? Hopefully you can. Dividing y by x, or sine divided by cosine for those particular angles, is positive 1. That's kind of nice. We just deal with cotangent the same way, reciprocate that. Now for our cosecant and secant, we're going to reciprocate, and they should end up being the same also, shouldn't they? Because they're reciprocating the same exact value. So negative root 2 over 2 becomes negative 2 over square root of 2. We've seen this before. When we multiply by the square root of 2 over square root of 2, you're going to get negative square root of 2 after simplifying the 2's that end up coming up. So just negative 2. And because of the same reason, we have that as well. I hope I've made it make sense on how to use a unit circle, basically. I'll deal with some kind of unique or different sorts of examples in just a little while. We'll talk about what would you do if you got just tangent of 6 pi or something. That'll be our first example. So when we're dealing with that, we don't necessarily have to find all 6 trig functions. It takes a little bit of time, especially when you have to rationalize everything. So we'll come back for that in just a little bit. Okay, last little bit. Maybe last big bit. I don't know. Let's see how fast it goes. Let's go ahead and we're just going to practice as quick as I can about how to find some of these trig functions. And I don't need to find all 6, maybe more than one revolution or negative angular measurement. We'll also talk about some of these arithmetic sort of math problems that involve some trig functions. So not all that bad. I'll also throw in some degrees up there just to get us used to it, to make sure that we can do the same thing. So let's take a look at something like tangent of 6 pi. Tangent of 6 pi. That's not on here, obviously. Just count your pi's. Count from 0 positively, which would be counterclockwise. 1 pi, 2 pi, 3 pi, 4 pi, 5 pi, 6 pi. So pi is half a revolution. That's going to be tangent of same thing as 0, or same thing as 2 pi, y divided by x. So we've made our rotations. We understand that we're coterminal with 0 degrees, or 0 radians, or whatever you want to consider that as. You're going to look at your y divided by x. That's what tangent does. It's sine over cosine. Y over x is 0 over 1, or just 0. How about secant of negative pi? At this point, the reason why I correlated your trig functions for you is that you should start identifying that cosecant and sine are reciprocals, cosine and secant are reciprocals. So I'm going to do it this way. I'm going to think negative pi, that's negative half a revolution, that's right here. The same thing as pi, coterminal with pi. So I'm looking here. I'm thinking that, well, let's see. Cosine would be negative 1. Secant is a reciprocal. Negative 1 over 1, reciprocate, that would be negative 1 still. Hope that makes sense to you. Hope you're seeing that we're co-terminating with something that's on our unit circle. We're just measuring it in a certain different way. And then we're looking at one of our original 3 trig functions and then maybe reciprocating. So with secant, that's x, that would be cosine, and then reciprocate that. How about, oh man, sine of 11 pi over 2. You know, you can also do something else. And this is going to get to our properties of trig functions. A nice segue to our next video, that you can do things like just subtract multiples of 2 pi. All of these things repeat themselves on an interval of 2 pi at minimum. So if we think about that, subtracting 2 pi, let's see, 6 pi minus 2 pi is 4 pi, minus another 2 pi is 2 pi, minus another 2 pi is 0. Get something between 0 and 2 pi. Subtract 2 pi until you get there, and you will end up getting that. So we can do that. So if I do that, well, that's it'd be 0. If I tangent of 0, still 0. Or secant, subtract or add 2 pi even. Adding 2 pi is going to see negative pi plus 2 pi is pi. That's exactly where we terminated. Same thing here, 11 pi over 2. If I subtract enough 2 pi's, I'm going to end up at some sort of coterminal angle. It's on my unit circle. You can also count them. Here's 1 pi over 2, 2 pi over 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. This is where that's going to terminate, at 3 pi over 2. If we subtract 2 pi enough, we're going to end up right here as well. So we're trying to find sine of 11 pi over 2. That's the same as sine of 3 pi over 2, or 270 degrees. That's going to be negative 1. Sine is our y-coordinate for any point on that unit circle. We can do something very similar with degree measurements. You'll also notice I put parentheses around some of these, and the reason is it's absolutely useful when you have math like in equations to put a parentheses around any sort of angle, degrees or radians, it doesn't matter. It's really nice to do that. Also, if you have negatives, we don't want to accidentally infer that's subtracting somehow, even though secant by itself makes absolutely no sense without some sort of an angle there. So when we do this, we like parentheses. So let's take a look at sine 45, cosine 60, and then add them together. It's all that same. So we're going to go quickly through it. Sine of 45 degrees says I'm in quadrant 1. Here's 45 degrees. Sine is the y coordinate on a unit circle. That's square root of 2 over 2. Plus cosine of 60 degrees. Here's 60 degrees, quadrant 1. Cosine is the x-coordinate, that's 1/2. Conveniently, they both have a denominator of 2, so we could write that as 1 plus square root of 2 over 2. You could also find a decimal approximation. I'm not going to go that far, but this is an exact answer for what that represents. Now, when we deal with things like cosecant of 45, I really need you to understand that cosecant relates to the reciprocal of sine. So what we're going to do is we're going to find sine of 45 degrees. We're going to reciprocate it, and that's what this is going to be. So here's 45 degrees, or pi over 4. Sine is square root of 2 over 2, but I'm going to reciprocate that. So if I multiply by the square root of 2 over the square root of 2, if I reciprocate that, I'm going to get 2 over the square root of 2. If I rationalize the denominator, that's 2 root 2 over 2, or just square root of 2. So this becomes square root of 2. I hope you followed that. I hope you followed that, hey, this relates to sine. It's the reciprocal of sine. So find sine. Got it. Reciprocate it. Got it. Rationalize it. Okay, that is what cosecant of 45 degrees is. They do make tables for this. That's fine if you want to have one, but I want you walking through the math. Now, because that's being multiplied, tangent of 60 degrees, tangent of 60, that's a little bit harder too. That is, take your y divided by your x, square root of 3 over 2 divided by 1/2. We're going to get the square root of 3. Multiply by the reciprocal, we get the square root of 3. All together, that's the square root of 6. That's an exact answer for what that represents because we multiplied those. They both had square roots. I hope it's making sense to you. I hope you're seeing where this comes from. I'm trying to make some connections between what these are and what our basic functions are and what our unit circle is doing for you. All right, just 2 more. Maybe try them on your own. See if you can figure out what cosecant of pi over 3 is. Remember that cosecant relates to the reciprocal of sine. So we locate pi over 3, quadrant 1. We find sine, root 3 over 2. We reciprocate it. And then we rationalize it. That's going to be the square root of 2 square root of 3 over 3. So this whole thing says, look at sine, I got it. Find it for pi over 3, we got it. Reciprocate it, we got it. Rationalize it, we got it. 3 times that thing is what this represents. That's it. Plus, so we got to add. Cotangent of pi over 4. Now this one's a little easier. Cotangent is the reciprocal of tangent. So let's look at pi over 4. Pi over 4 is here. Well, let's see, tangent would be this divided by this, or 1. Tangent of pi over 4 is 1. Cotangent is the reciprocal of 1. Well, that's also 1. So if we simplify, we get 2 square root 3 plus 1. Okay, our last one. We're going to take sine of pi over 4 multiplied by 2, tangent of pi over 4 multiplied by 3, and then add them together. So sine of pi over 4, we should be fairly confident in doing this at this point. Sine of pi over 4 says, look at your y, that's root 2 over 2. Plus 3 times tangent of pi over 4 says, take your y over your x, that's going to be 1. Simplify them and we get the square root of 2 plus 3. Well, I hope I've made that make sense for you. I hope that you're really seeing how to use a unit circle. It takes some practice, of course, and some of these things like cosecants can kind of mess you up a little bit, but make it go down, or think about it in terms of its root function, its reciprocal function. Figure that out, reciprocate and rationalize, and typically it goes okay. Now, the last question is, what happens if you have some of these angles that aren't on your unit circle, like 28 degrees? Well, that's not on here. How are you going to figure out sine and cosine from that? That is what your calculator is for. So if we have sine of 28 degrees and you cannot locate sine of 28 degrees or pi over 12 or 1 degree or 1 radian on your unit circle, use your calculator. That's absolutely fine. Just make sure that you're in the right mode. You see, on your calculator, you'll have something called degrees or radians, deg or rad. You want to make sure that you're in the appropriate mode before you start plugging stuff in. So try it right now. Try plugging in sine, or press sine and press 28. If you're in degrees, it's going to give you the right thing. If you try to do sine of 28 radians, it's going to be completely different. So if you're trying this on your calculator right now, notice that these are approximations. They're not going to be exact for you. Sine of 28 degrees is about 0.47. Why? Well, 28 degrees is just less than, hopefully you have a unit circle in front of you right now, 28 degrees is just less than 30 degrees. Sine of 30 degrees is 1/2. So sine of 28 degrees is just below 1/2, and that's exactly right. That's what it is. Now notice I talked about degrees and not radians because we're in terms of degrees. When we start talking about radians, well, we're going to have to switch our calculator. So you can do things like sine of 28 degrees in terms of degrees. Sine of 1 degree. 1 degree is about 0.02. Why so small? Now picture this in your head. 1 degree is just like that, just barely up there. Sine takes the y measurement, the y value. It's very close to 0 because it's so close to that x-axis. It's barely lifted up, so your y-coordinate doesn't have time to move very far with that motion. When you see a lack of a degree, you are talking about radians, and your calculator must be changed into radians. So what we're going to do is go into your mode and click on radians and then plug this in. So cotangent, some calculators have cotangent, some do not. If you don't, what would you do? Well, you plug in tangent of pi over 12 and then hit 1 over that and find the reciprocal of whatever you're getting in this case. Try it on your own. Make sure you're in radians and you should get 3.73. Now let's look at this. Let's look at the difference with that. Is there a difference between 1 degree and 1 radian? Absolutely. We know 1 degree is 1/360th of a revolution. 1 radian is the angle that would take to make an arc length equal to a radius of 1. Well, that's way up there. There's only 2 pi radians in an entire circle. Well, 2 pi radians, that's like close to 6.2 something, almost 6.3. So there's only 6.3-ish total radians in one circle. That would be almost 1/6 of that circle. That's going to be much more. Well, what this would work out to is sine of 1 radian is going to be the y-coordinate of whatever that swept out angle is. In our case, 0.84. That's fairly close to pi over 3. Not exactly, but close. All right, last thing. So what about the point negative? I think I said last thing like 5 times, but last thing. So the point -3, 4. That is not on a unit circle, kind of obviously, right? Because the radius would have to be 1, and this is way more than 1. Wait a minute, how much is it actually? Could you find the radius? Because that's what it's going to take in order to find sine, cosine, tangent, trig functions of this. Yeah, you can. If we understand that this would make a right triangle, our height is 4, or let's say our opposite, consider that opposite, would be 4, and our adjacent would be -3, or 3 in terms of a measurement there. You can use Pythagorean theorem really nicely. So leg squared plus leg squared equals the hypotenuse squared. That's going to be 25. If you take a square root, r equals, by rights, it equals plus and minus 5, because you took a square root of both sides. You should have a positive and negative. But because we want our radius to be positively defined, otherwise you're going to be in the wrong quadrant, positive radius would be here, negative would, you do this and then flip it over. We know that our quadrant is in 2, so we want a positive radius to be in quadrant 2. We can do some other things with negative measured radius, but that's usually reserved for like polar coordinates when we get there. So our radius we're going to say is 5. So we know this is 5. If we want sine, cosine, and tangent of that angle, then all we really have to do is take the y over the radius, x over the radius for cosine, or the y over the x for our tangent. Notice how the signs still match up. Our sine needs to be positive, our cosine will be negative, and our tangent will be negative. All students, remember, sine should be positive in quadrant 2, and it is. Cosine should be negative, and it is. Tangent should be negative, and it is. So if we wanted to find this, this is the reason why I showed you that triangle at the very beginning of talking about a unit circle, is that you would understand that we can make a triangle out of it. And the only reason why we get just a y on the unit circle is because the radius is 1. It really should be opposite over hypotenuse. Well, that's what we're going to do. But in terms of sine and cosine and tangent, our opposite is 4. It's the y. We just have to divide by a radius that's not 1. So dividing by that radius sort of shrinks down into a unit circle idea. So we're just going to divide it by that 5. Cosine theta, same thing, would be adjacent, or the x over our radius. Make sure you use the negative. Tangent is going to divide your y by your x. You can divide sine by cosine. The 5's will cancel, you get negative 4/3, or 4 over negative 3 is negative 4/3. I'm going to leave it to you to be able to find the cosecant, secant, and cotangent. It'd be very easy. Just reciprocate, reciprocate, reciprocate. But I did want you to see the signs. That sine is still positive, cosine, tangent is still negative. I did want you to see that you're still taking y for sine and x for cosine and y over x for tangent. But if we do not have a unit circle, if we have something off of the unit circle, you basically have to divide by that radius. So find it, and then we'll convert it to something that's similar to a unit circle. So we're dividing by 5, and you're going to see right away the connection between trigonometry on a unit circle or not a unit circle and the triangles I drew at the beginning. So I hope I've made it make sense. I hope you're really seeing the interplay here. I've done my best to explain it to you in several different ways. Hope you're doing well, and I'll see you for another video.